aspect in this episode. And this time around, we are going to be talking about some statistical tools that are used in analyzing data. We have dealt with group data and we have manipulated group data to get some basic interpretation from the group data. We have also started on group data when you have large chunk of data, you want to deal with them, you want to analyze them to infer some information from them. Now we are moving to some tools, some mathematical tools, or we actually call it statistical tools that are used in manipulating our data, that are used in analyzing our data, that are used in making our data more clearer. The first one we are dealing with is bar chart. Bar chart is a rectangular shape item that has in between it equal width. Bar chart. It's a rectangular bar. The bars are rectangular in nature, and in between each of the bars, there are the same distance between them, equal width between them. What I'm saying will be clearer when I have a practical example. What we are talking about is that let's give ourselves an instance. From that example, we will understand it better. Let's assume that we are told that we are given an example that the item purchased to show the items, show the information in using a bar chart. Show the information using a bar chart. So in that case, if you have to use a bar chart, I was trying to explain to you the other time that a bar chart is a rectangular shaped, diagram that has equal width between them. So what I said is that although most of the time you are constructing your bar chart, you have to use a graph book to construct it. And if you are using your graph book, you have to consider the vertical axis and the horizontal axis. I think we are dealing with quadratic graph. I would have loved to delve into it better. But since we are not dealing with quadratic graph, we just need what we need to deal with our problems here. So when we have a quadratic graph, you will see the vertical line and the horizontal line. The vertical line should represent the y. In every graph, you will have the vertical line, which is your y, the horizontal line, which is your x. And if you study your graph book very well, you observe that if the two lines meet, this is the origin. The one on the right hand side of the x, this is the positive x. The one on the left hand side of the x is the negative x. The one at the upper side is the positive y. The one at the lower side is the negative y. It means that this one will be negative, this one will be positive. Right. But if you are dealing with information to be represented on a bar chart, all the information will be positive. So we are not going to be using this side of negative of x or this side of negative of y. We will only be making use of all these sign notation when we are dealing with a data that represents negative values, or possibly when you are plotting your quadratic graph. So in that case, we have this information to be represented. These are the years that we are considering. These years are said to be the data, because they are the data that we are going to vary with your items. This year are your data, and these your items here, they will be frequency. How many data appears in this year? How many items delivered? The Ojibwa school bought 200 items. In this year, 300 and so on and so forth. So in that case, we need to vary our data. Your data will always be on the x-axis, which is the horizontal axis. Then your items purchased, which is the value, the item that are purchased, which changes with time, that will be on your y-axis, which is your vertical axis. So most of the time, if I have to plot it in a graph, we have to choose a scale. But since we are not plotting it in a graph, we just want to demonstrate it to us. The maximum value we have here is 1,500. You know, to represent our data on bar chart. We don't have negative value for our data, so we just have it represented like this. So on our y-axis, we can see the values of y, which will represent the items. The lowest one is 200, so let's just have it like that. 200. The next one is 400. the next one is 600, the next one is 800, the next one is 1000, the next one is 12, and the last one is 1400, then the last one is 1600. So for our x-axis equal distance between them, don't forget we are plotting this in your graph. You will have chosen a scale to represent them. Let's say this is 1991, this is 1992, 93, 94, 95. So this is 1991, 1992, 1993, 1994, 1995. So in that case, we have the first one will be 200 on the y-axis. So I can have it like this. This 200. So on the y-axis is 200. On the x-axis is 1991. So it's within that x-axis and y-axis. The next one is 300. 300 will be coming in between this. Then let's assume this. One thing you have to note is that the size of this rectangular shape must be the same. If you are using 2 cm for this, it also has to be 2 cm, and the space in between them will also be the same. So the next one is 400. So we go to the y-axis, which is 400. Then we mark it like this. The size of this thing will be the same. This is a demonstration, so we can't get a perfect representation here. So the next one is 700. 700 will be in between 600 and 800. So we have it represented. The distance between them, between each of the bars, must be equal width. That's the definition of a bar chart. Then the last one is 1500, which will be in between here. Sorry, the distance will be the same. I'm trying to represent this as much as I can. The distance will be the same. So in that case, the width of the bar is the same, and then this corresponds to the y-axis and the x-axis. Now this one gives us the representation, the pictorial representation of our data, and you can see that anybody that looks at this will get the picture of the items purchased in each year as they vary with themselves, rather than the frequency table. So the pictorial representation gives us a direct, and clear, view of our data. Another statistical tool in representing our data, and that is what we call pie chart. Pie chart represents data using a circle. It implies that if you are to convert the given data into a circle, you have to convert it into degree. So I'm going to demonstrate to you how to convert the given data into a degree. Given this example, we are given that the scores of students in this test are as follows. We have English score 10, Maths score 4, Econs 7, Physics 3, Chemistry 2, Biology 4. I have to represent this score using a pie chart. If you are to represent using a pie chart, these are values that are in ordinary number, but you have to convert it to degree. Then the first thing is to draw your table. You have scores, then you have sectorial value. This one is in degree, of course. So in that case, we have 10, we have 4. Total here is 30. So take each of them to angle in a circle. The total angle in a circle is 360. So you are finding the fraction of this that will occupy the angle in a circle. That's the given score divided by the total value times 360 degrees. Of course, this one cancels this. 3 here, 1, 3 times 12 times 6, and this 120. So we have 4 over 30 times 360. This will also always be 12. 12 times 4, 48. 4 over 30 times 360, and that's going to be 12. 12 times 4 is also 48. Of course, this is what we have. If you calculate this together, this is going to be 360 degrees. So, and the third statistical tool that we're going to demonstrate, and that will be the last one, is called an histogram. Histogram is also look like a bar chart, but the only difference between an histogram and a bar chart is that instead of each of the bar to be spaced to have equal width, histogram will be joined together. each of the bars that you construct in an histogram must be combined. They have to be enclosed rather than being spaced like we have in a bar chart. So using the same example that we use in our histogram to represent our data. So in that case, we have the same representation that we have dealt with before. So this is your years, your x-axis, and this is your items for your y-axis. Exclusive explanation was done in the first thing. So the only difference is that this one is 200 when this is 1991. So you have your bar chart represented, right? Then for the second one, instead of you to have space in between it and the second one, that's 300. 300 will be somewhere here. So what you do is that combine it with this. You want to be somewhere here, so you combine it with it. There's no going to be space between this first one and the preceding one. Then also 1993 is 400. 400 is going to be here. It's going to be is this point, and you combine it with this. Then the next one is 700 is going to be here. Then you combine it with this. There are measurements which you should also follow if you are using your graph book. Then the last one is 1500, and that will be somewhere here. You have to combine it with this. Yeah. So the only difference between an histogram and a bar chart is that the bar will be joined together in an histogram, but the bar chart they will be spaced.